virtual lecture. He's also here. Thank you. And I'm here to present to you today the OpenDataCapture platform, which is something that we built out of the Douglas to meet the needs of clinicians and researchers at the Douglas, but being an open source platform and it be useful to many other people here, either online or in the room. So I'm going to present OpenDataCapture. First of all, the Douglas Neuroinformatics Team. I'm the project lead. However, a lot of the work, or most of the work, is actually done by our English programmers that are actually part of the team. In particular, majority of the work for data capture is right now was done by Josh, who's taking a well-deserved month vacation after finishing the 1.0 for our beta inside the Douglas. So he's unfortunately not here with us today, but really focusing on material that he produced. So some quick definitions in terms of what I'm talking about. What do I think about as data? And the reason for this is, this is an imaging center here, but also a research center, but there's also clinicians and clinician researchers and so on that are involved in this. So what do I mean when I talk about data? Any kind of semi-quantifiable measure or group membership. So we're really talking about anything numeric, group-based, anything where you can capture categorizations. That's all considered data in the kind of conceptualization that I have. It means things like test scores, demographic information, and we want to be able to structure that. Age, clinical data versus research data. From the perspective of my thoughts about data, the only distinction between that is consent for use. So if someone consents to use their data for research, then it's research data. Otherwise, anything it could be collected in exactly the same way, could have the same measures. If consent for research, then it's research data. Otherwise, it's clinical data. And there's this platform is designed to be able to handle both kinds. So it's important to be able to have a clear definition of how that works. What do I mean by personal identifying data? Things like name, address, unique government ID numbers. So that's where you can then uniquely identify an individual. OpenDataCapture versus Douglas OpenDataCapture. Of course, this was all built for the Douglas Research Center as our primary use case, but we're making an open platform. So I just want to make a distinction here that some of the details here are Douglas specific, but the software platform itself is a generic thing. Open source. What do I mean by that? For anybody who might not be aware of what kind of the definition we're operating under here, the code for a computer program available for inspection, reuse, and modification. So that is, when I say open source, I mean that the software we're going to be presenting, you can take and use as you wish under whatever use cases you care to. And finally, open data is a completely different concept. Data collected, shared freely with no restrictions. This has nothing to do with open data. We're not talking about open data. We're talking about having a platform that can collect data. Keep it all inside the platform forever and only have it for internal uses, that's fine. That's not what we're talking about today. Okay, so the background, how did this actually come to be? Clinicians and researchers use a whole bunch of different ways to collect data. Paper, Excel, SurveyMonkey, Castor, I don't know, which is a EU product, RedCap. Some of you may have used RedCap before. Lots of other things from other institutions that you may have built internally or that you've seen from some other institution. Often these things are set up by some RA, and then when they leave, they're left unsupported. So you might have a lovely web-based form to do some kind of data collection, but the person who set it up leaves the lab because they're successful and they go off and do something else. And the problem is now the laboratory might not have the ability to update it, modify it, re-implement it somewhere else, all those kinds of things. Data is often stored or captured outside the institution in these setups. So if you're using SurveyMonkey or if you don't happen to have a RedCap installation internally, then you end up doing your data collection, which the research expert board doesn't care about, or doesn't like about your setup rather, because you're collecting potentially identifying data or potentially sensitive data outside an institutional setting. So an supported in-house solution is needed. This OpenDataCapture platform is designed to be deployed internally, but to meet the needs of a research and clinical institution where data capture can happen both inside and outside. So the history here, we were supported through HBHL, which started the D3SM, the digitization of Douglas mental health, which is an umbrella that covered a whole bunch of things inside the Douglas to enable digitization of psychiatry. And we're one piece of that. The open science team at the Douglas did some pretty extensive needs assessments across clinicians and researchers saying, what are the kinds of things you need? And the thing that's constantly coming up is, I need a better way to handle my data management, to handle my data collection, to have it clean and organized, because I don't have the ability to do it myself, because these are small laboratories that are not primarily computational. They need support. We started by first investigating a whole bunch of other potential solutions of other open source platforms, what are other people using and so on, whether or not they would meet our needs, given like how all the needs assessment went, and in the end decided we're going to build something. So we build our own. First commit was in November 2022, and last week we had our 1.0 on the GitHub, which is deployed internally for our first use case. And we have a research project that's 10-year longitudinal research project. It's going to be using this for data capture, moving from another platform. So we're only doing 9 of the 10 years, as well as one clinical project. Currently planning to use this for that. So what's the philosophy of how we want to build? We wanted to build this. We wanted to make it open source. We wanted to make it documented and easy to install. So I have as a previous life, I also did system administration. I want to be able to grab the software and install it with sufficient documentation that with my standard skills, I don't have to ask anybody any questions. Things should just work. And that means that it should compare to any other nicely managed open source platform that exists for lots of other things that are unrelated to science. I want it to be at that level of ease. And that's what we're targeting for in terms of the installation. There's our GitHub. And we wanted it to be open source, so it's GPL licensed. We wanted modern web-based interface. So that means it needs to be a responsive design. It runs on any size and shape of device, from a phone to a big screen. No need for apps or any of these things, just web. Modern software, so we wanted to use modern development tools and things in there. So that means we're building this, TypeScript is the standard for the web on these kinds of things. Containers for how to manage the dependencies and the installs and so on. And finally, a modern NoSQL type data management, which means that we don't have to worry about, say, rewriting the entire data schema inside every time we do a modification of the platform, which you may have to do, depending on your initial design in a relational database like MySQL or Postgres. Front end and back end separated, so we wanted to be able to use this programmatically. So if you have your own software tool where you're going to collect some data and you want to store it in a managed way, but there's no form associated with it per se, that means we need APIs to be able to do all these data uploading, data downloading, insertion, have all that be validated, and then have a separate front end, which is just in this case, single page JavaScript web application. And it's also built on the Open API specification, which means you can grab it, parse it, and generate automatic skeletonized code for Python or R or any other coding platform that has an Open API implementation inside it. Natively longitudinal, so definitely we expect to be measuring subjects more than once, but not in the concept of cohorts or anything like that, just the idea that there's a date and a time associated with every piece of data that's ever put in the system, and that's a way you can represent longitudinal measures. If you want to do time points, you can transform that kind of concept after the fact, but here we're just talking about native time. And secure. We wanted to not store any PID because that makes the web happy, that makes it easier for us to kind of slowly make our way into potentially the clinic as well, which again makes hospital IT people happy to not have to store any of that stuff, because unfortunately the response you can sometimes get from those kinds of guys is open source, but what about security? Not a great experience sometimes with that. So within hospital data storage, you can deploy it internally. You don't have to do anything in the cloud. Privilege separation, obviously, for being able to, so everything you can do in the platform, you can have a user either have the right to do it or not. Now there are standard, specific classes of users, but you can actually very fine tune that. So you can have API users and things like that. If you've used other platforms, you might get an API key and get full power on everything, which is not exactly secure. And we wanted to take advantage of encryption where we could for when we have to somehow go outside hospital IT walls, the firewall walls. Quick tech dump for people who might be interested in this. We're just going to breeze through it, but this is how we ended up implementing it. TypeScript, REST API, single page JavaScript front end, comprehensive JavaScript runtime with encapsulation, it has a language for writing the forms built in that's JSON-like. You can encapsulate with an iframe any kind of existing online instruments, so that if you already have an instrument that from some other that you've written in some other tool, you can wrap it and collect the data out of it without having to rewrite it inside the platform, which was really important for being able to use existing instruments that people have already published or are already using. We have an isolated gateway service for at-home evaluations. So there's a way to do things on the fly outside of the institution, even though we're very institution-centric. With encryption to actually manage all the data handling on that side of things. So that is data at rest on that gateway service isn't readable, which is really important. It's all pull only, so there's no need to open any holes in any firewalls. So as long as you can get out to the internet from your institution, that means the gateway service can work. You just have to be able to, any old little cloud service somewhere, and all the data is encrypted. And then, of course, we ended up building everything in the Docker containers. So what does the architecture look like for something like this? So here's my generic hospital internal network with my firewall protecting the hospital from cyber attacks and so on. We have backend API, which is written in TypeScript, Node.js, talking to the database. So that's our Mongo container. These would all be typically containerized, but they don't have to be. Then the front end server, which is separate, which is just simply like a JavaScript application. And then inside the institution, you might have a tablets in the clinic where you have somebody coming in and filling out some induction forms of some kind, or you have a researcher at a clinician computer where they're logging into the platform and filling in, having an event and filling in some forms, having a visit. And then outside, we have the gateway server, which lives in a cloud service, AWS, Compute Canada, wherever you want to do it, DigitalOcean, DreamHost, whatever, that we can push assignments out to, and then you can have a client PC, a client phone, a client tablet for doing doing the instrument outside the institution. And all of this data ends up being encrypted. We'll go over the details about how we achieve that, the technicalities of that. Security, avoiding storing PIDs. So we wanted to be able to enable clinics to actually be able to just use the identifying information they know about an individual, whether that's hospital ID or users, their legal name, their birthday, and so on, without storing it. So how do we achieve that? We achieve that with hashing. So I'm going to go over a quick detail about how you would achieve this, but we use a secure hash function for being able to take whatever PID you want to use to identify a person, and for example, take my name here and my name and mail, put it through the hashing function, and you get out this long semi-random string. So this process is deterministic. That is, it will that same input would always produce the output, but I cannot go the other direction. And I'll demonstrate to you why I can't go the other direction. Here I've got the entire text of Frankenstein, which is 7,000, 8,000 lines, 78,000 words, or a whole bunch of characters, 48,000 characters. I could run that through the hash function too. That's the same length, right? So I think you can see, like, on a computational basis, it's impossible to reverse this to get the original piece of information, because that's literally a type of compression of the info. So that means that I can store and identify an individual inside the platform using PID without having PID in the platform. So if I already know it, in the case of being the clinician who's sitting down with clients and so on, I can look up a person by doing a query. But if I were to look at the database, there's nothing inside there that actually identifies the individual. So that's how we're achieving kind of this anonymization factor inside the platform. How do we handle encryption? So I said we want to do gateway, and we wanted to be able to have this external gateway, but we don't want to have the firewall open, and we don't want to have any data sitting at rest on non-hospital systems that is in any way readable. So how do we achieve that? Well, the way you can do that is with public-private key pairs, which is how HTTPS works on the web, how SSH works if you've ever used that. Anyone with the public half of the key can encrypt data, and only the private half of the key can decrypt that data again. There's algorithms that have been used for many, many, many years to achieve this. And this is how, you know, online banking and everything happens on this side of things. So in each assignment, the gateway receives a unique public key. And when the user completes the instrument, it is immediately encrypted using that public key. And now it is impossible for anything to read that, but the private key, which is only on the back end inside the hospital. So that until you pull that data back down and decrypt it and insert it in the database, it's not readable by anybody else. And so that's how we achieve that. Encrypted data, as soon as the form is submitted, encrypted and searched. So we have the download and then use the private key to encrypt. What does that look like? Well, you can actually do this on Linux and command line fairly easy in standard tool. We've got an RSA public key. I've got my secret data that I'm going to encrypt. I go through encryption with it, and I get my, what we call ciphertext. And now I have a private key, which turns out it's a little bit bigger, which I then feed it through and do encryption, and I get my data back. And so that's how we achieve that. And so you can separate those out. You can give away the public key freely and safely. And the private key stays internally inside the server, inside the interface. So in summary, we're not using PID, we're not storing PID, but we can still use it. We can take advantage of it. You have asymmetric gateway encryption, fine-grained permissions for admin, group manager, clinical staff, and you see that when we do the demo, that there's differences in how the access is inside. We can do local storage inside the institution without having to need any cloud deployment like things. And we have pull-only communication in the gateway, no need to open up any firewall holes using it. So what does this application actually do? So I've talked about kind of the technical structure underneath it. What do we have for features about what it does? We have forms. Client-facing form where the client might be answering a bunch of questions about how you're feeling or whatever it happens to be. Standard web forms. Locally or via the cloud service. Then you could have clinician or researcher-facing forms. So if you think about, for example, the MOCA, the client completes the MOCA on paper because there's drawing components and so on. And then you do scoring, but you want to log all those sub-scores and then have the final score be automatically calculated from that. So that's where you can have an RA or a clinician or something do data entry on that side of things. And that kind of form is exposed just to the user, just to the clinician, right? That's not really a client-facing form, but it's available in the platform as well. You have guided forms where it's saying you're going to ask these questions and that's questions. You could do logging after the fact. And then you also get a summary page. So again, this is the idea of, there are already clinics that are collecting clinical instruments of some kind, and they might be inserting some of those numbers into a report in the EHR. Clinician might be already doing it, or a nurse practitioner and so on. We want to be the first place where that data gets collected, because in an EHR, it's often not structured, so you can't get those numbers in an easy way. But if you collect it first in the platform, we give you a nice summary, which you can copy and paste into your clinical report, or print it, or so on, after the instrument was completed. So we have the ability to structure the data and then provide still kind of the standard feedback. And that includes being able to actually compute downstream results from those forms. So for example, I said the MOCA has a bunch of subscales. You don't need to enter the final value for that. It can compute that. But there are other things where you say, oh, if the value is greater than this, or less than this or something in the test, it can report the rendered value for that, and give you that feedback. Standardized instruments. So we want to provide as many publicly available standardized instruments inside the platform. So if it's already public and has the appropriate licensing, we're implementing it in the platform as we have time, so that it's just available in a standard install. Then we have interactive instruments. So we can embed existing web-based code of various kinds. Runs embedded in an iframe. So that is that it's isolated from the rest of the platform slightly, and then we collect it. And then, of course, we have the gateway, encryption, backend pulse. So I just want to compare quickly against the other things that might be around. We're free. RedCap is kind of free. I'm actually not sure whether you pay them anything, but you do some kind of license. No, sorry. You need a license. It's an institutional thing with a license of some sort. Exactly. I'm not sure exactly how that licensing process works, but we haven't gone through it. Castor, last I checked, Castor was like $10,000-$20,000 for a year. It's super expensive for some reason. Using modern tools, it's not PHP like RedCap's build. It's modern TypeScript stuff. Easy to use, we would like to say yes, and you'll see what it looks like. Interactive instruments, yes, remote assessments, and an API. Kind of aiming for lots of nice features on there. Now we can get to demo. So we still shared? Good. Yeah. Okay. So here we have our demo platform, the OpenDataCapture, and it's so this is the demo platform, and we have a number of demo users created, which we can auto log in here. It's multilingual. We have it implemented in English and French for all the things we're doing, but you can do as many other languages as you want. You just have to provide all the translations in the code base. You know, contributions welcome for other translations, and of course the forms can be the forms are all multilingual as well. So that you can have the same ones. So the data, even though it's collected in different languages, it's actually underlying, has the same data model for that. So I'm going to do it like that. And we also have dark light mode if you like that kind of thing. That was fairly easy to do in modern. Again, by using a lot of the modern stuff, a lot of these features are super easy to implement. And so we like using them. So we're going to log in here first as a standard user here, François, for the psychosis lab. So we have some group identification that happens inside the platform. And he's a standard user, and so he has some minimal permissions inside the platform, so we can see what the basic access looks like. We have our basic data entry person. So this might be something like an RA, who actually can't see the backend data in the system, who can just administer instruments. So all we have here is start session, we have administer instrument, and we have end current session. We have the concept of a session for when we're doing data collection. And so that session can either be, we're going to do it now, or it was retrospective, in which case we have to put the data in. So if you happen to collect a bunch of paper forms over the week, and then you have 2 hours of RA time on Fridays, where they're going to do your data entry, then they can actually put in when the data was actually collected and do the data entry and fill out the instruments as though that you're transforming a piece of paper into a structured piece of data. That's one way to do that. We have 2 ways to identify here. So the custom identifier mode is the classic one for research studies, where I have ABC001, and so you can use that to identify the subject. That gets hashed anyways and used inside with the hashing system. Or as I covered, there's the personal identifying information one. We have name, last name, date of birth, and sex of birth. That's a way to start a session. So I'm going to go back to custom because it's easier to type in quickly. We'll do that. We're going to do an in-person assessment, and we'll start a session. Unfortunately, this is running on a VM that is not very fast. Excellent. It's having some timeout issues currently. Wonderful. Hold that again. As nice as Compute Canada's free VM service is, it is massively IO starved, which is causing us some issues, unfortunately, right now. So now we have a session started. We have our session in progress. Now we can go and administer an instrument, and here we have the instruments that are available. Francois is a member of a particular research group, and the group manager gets to decide which instruments are actually available to see in terms of this list. I believe there's actually just all of them right now that are inside the demo unit we built. But we have dynamic search for the list, also by tags. And then finally, we have a language selector. And so language selector in this case means there are some times where an instrument might be explicitly a French instrument versus explicitly an English instrument. The idea to think of is that in English, there are a number of words that that people mispronounce because the pronunciation of those words is not according to what the default rules are. There is a test associated with that, which I don't remember the name of right now, what is used as a type of a cognitive test that doesn't work in French because, first of all, they're English words, and secondly, French has much more standardized rules for pronunciation in general. But however, there is an equivalent French test, or what is considered to be an equivalent test, which is whether or not you get the gender of certain words. There are genders that there's some kind of broad set of rules that people learn, and there are certain words that break that. And so that's the equivalent one of, do you remember those as being a type of a cognitive test? And that's an explicitly English and an explicitly French test. In general, these tests are flippable. Anything can be flippable at any time here in terms of the language to switch between English and French for the platform or for the client. For the general ones where they're multilingual to begin with. So here we have kind of our summary of what the questionnaire will be. This is actually one that we made as our first demo instrument, and we can go and run it. And we have our questions. How happy are you? How satisfied are you with your personal life, your professional life? Are you satisfied? Yes. And then we can submit that, and we get our summary, and we have that inserted in the database. And so you can go through and administer more instruments, or you can say, that's all I've got to go. If this was on a piece of paper and you're copying it in, then you can do all that kind of stuff. And so we're going to log out of Francois because that's all the rights that he had. We'll go to our top-end manager, which is Jane Doe. We have a warning here. Initial warning can come up with the other one. I think I'll have to check that. But this is not the HR. This is just for data capture. So here she gets a summary of the clinic, and there's actually, she's a manager at 2 different clinics, and we can see subjects and records. We can switch between it because every piece of data that's collected is associated with a particular group, even though inside the data itself that they're not separated except for that tag, which means you could have multiple clinics collecting data on the same subject, which at some point in the future, given consent, you can combine, but to begin with, it's all separate. Jane Doe has that data hub here, where we can see the existing data. This is all fake data that we randomly generated for the demo, and we can take a look at that. Look at one of them. We can do. This is where the data export happens. If we want the data out, open it up. We have assignments, and this is how we have a external link created for a user for a client to be able to do an instrument somewhere else. So we've got a couple of outstanding ones, and they have the gateway link, so you can send this to them via whatever mechanism. We're not currently thinking about integrating the notification or email system. We're saying you guys have your own methodologies in that way right now. So the idea is you can copy and paste the link out, or you could build, because there's an API associated with this, you could automate this in some way on your own with your own tool. But that's the external gateway. So this instrument happens somewhere else and is a unique, randomly generated URL for the individual, where they can go and fill things out. They also get the nice color change, and they get, of course, the language. This language setting is based on your browser. So if you prefer English or French, you will by default get the one you want until you explicitly override it to something else. Which is that it's remembered. So then they can go and fill in their instrument, send this to your client, the same one again. We have conditional questions. So here, why do you feel you're satisfied? You're dissatisfied? Wi-Fi didn't work. Existential crisis.
Emails and research grants.
And yeah.
CIHR.
CIHR. And so on. And then we have the submission, which hopefully worked on the back end there. We also have some basic visualization, although we're not primarily aiming for visualization as like a primary feature set right now. But if we're going to have clinician users, the idea is if we're going to be once we have clinicians collecting in the clinic, they want to be able to look up a subject and say, how was their happiness over time? Here's the table. Or we can actually graph it and say, okay, I have this questionnaire and I have my overall satisfaction over time, along with a group measure, lead value, and so on. This is okay right now, but I think we would probably overhaul this pretty heavily if we had a lot of regular clinical users. One more thing to see here. Let's just go back to the custom identifier and start another session. Is the interactive instruments, because we haven't seen that yet. So we can administer an instrument, and here we have from the Many Brains project, we have this instrument, which I'm not going to time out on the back end. Oh, good. So this is an interactive instrument that's embedded. It's completely written by somebody else. It's JavaScript and a web page. We stick it inside, and then we can capture the data that comes out of it. So we didn't write this instrument at all. We wrote the wrappers that are around it. have face recognition. We're a little bit low resolution to see all of this here. I see there's a rendering bug where we get to interact with all those. Whoops. That clicked the button there. And we can go through the instrument. You can see here the button interaction is conditional on whoever built it, unfortunately. That part of that button isn't actually functional. You have to actually get it on the text. But we're implemented one-to-one from whatever the original one was. We're not interested in necessarily forcing everybody to rewrite that entire platform feature. It's a long instrument. I tried this out and yeah, I was trying this out and I was like looking at them going, I'm not sure that any of those 4 words appropriately describe. It's like, are they supposed to check? I had to check, is there a bug in this app, in this thing? Are there supposed to be other emotional forms for this? But it turns out no.
So all the WTFs. All the spaces.
And then we're done. And it's most of that data, there's no results that showed up here because there's no rendered measures, but that all went into the database for that individual. And so as I said, there's the summary page. We have a copy to the clipboard. We have a download where you can get a CSV representation of just this individual piece of data. And then there's a print button, which does like the media print and gives you just the summary page so you can print it out if you wanted to get a paper representation of that. So that's the platform side of things. All of this has documentation. That's in some cases auto-generated, some cases manual. The manual one will obviously kind of lags behind a little bit in terms of because development is very active. But for example, the way to generate all the forms is all auto-generated. We have our full UI toolkit with all what the language is for writing the forms with examples for everything here. And where's the other documentation? And we have a playground to build the instruments, which I broke this morning. And so I can't currently show you, unfortunately, because I thought I shut off something that I didn't know I should have. But the playground allows you to write the language for these forms here and have it dynamically updated and have the instrument actually render right next to you. And once you figure it all out, so you can go through and run the instrument without being inside the platform on the webpage. And so you figure it out. You get all of it. You write the instrument in this like nice JSON format, and at the end, then you can just insert it into the database and you store it. So the instruments themselves are actually not part of the platform; they're part of the database because they define the database schemas. So that's the end of the demo. A few more things right before the end. So what's next? So we're going to implement a whole bunch of standardized forms. Anything that's public. I got a big bunch of GitHub issues of things that people are interested in or things that I've come across and like I think some people like that instrument at some point. You know, it's focused on psychiatric to start, the Douglas, but you know, we're not. There's no reason this can't be for anything in terms of forms. In particular, though, we're cooperating with the McGill/Douglas Rep to have a standardized demographics, which would be really nice so that everybody who goes through the platform ends up with at least a basic questionnaire about, you know, age, sex, gender identity, ethnic background, income, like having the same kinds of measures across all of them. We had a mocked up one that was based on the census, kind of long form census for Canada, which we rely on Statistics Canada to pick appropriate lead points between groups and good in terms of the income groupings and so on. So we're probably going to build something based on that. For some kinds of tests, there's these population reference measures. So if you've done some clinical tests, they might have a lookup book where you can see, oh, this subject is Z+1 or Z+2 or Z-2 on a score. We want to start implementing that component in the form. So that means like if you fill out a form or fill out a test, you can see as a result how far are they away from the standard, and that's of course like at the request of clinical users who want to be able to use this as like a way to not have to go and look up the book and facilitate that feature. Standardized interactive instruments. So ManyBrains has a bunch of them. We have 2 implemented so far. We want to do more. We want to find other standardized instruments that are open source that we can just implement. We had the launch, now bug squashing, because I found a few bugs just demoing here today on the different screen size in terms of where that padding should be. So find those other things. A request from other clinicians has been kind of supervised instruments where you have something being presented to the client and then the clinician themselves sees something else, so kind of a two-screen kind of platform where you might be presenting, say, the request came from the concept of, I want to show pictures of things to my client and have them say what they are. And I know what the right answer is, and I want to score whether they got it right or wrong, but they don't get to see it. That kind of process. So there's a naming identification task that is something like that. We want to build, looks like we'll build something directly like that for one of our clients. And so we'll have that kind of feature set in there. That's probably a function of how you write the instruments more than the platform itself. But there'll be a first time for how to do that properly. Real-time tracking of the subject feedback and more instrument types. So far we've talked about like these forms and interactive stuff. We want to expand, so we have a concept of an instrument as a generic object inside the platform. So that means we can have instruments that have, you know, some kind of binary data, like say an activity tracker that might be streaming data in or so on. The gateway can be expanded to handle that kind of feature. Arbitrary binary data, anything, you know, if you wanted to upload and store things. So we need kind of a file management backend, and that's somebody's working on that right now, figuring out how we build that. You know, arbitrary binary data, of course, MRI data, maybe DICOMs or NIFTs or something like that. So there's the arbitrariness of storing the file, and then there's the like, well, this is MRI data, we could visualize it or compute things. Progressive web app. So we said we're not making apps. We don't want to make an Android app and an iPhone app and so on. But there is a feature in HTML, JavaScript that's called progressive web app, where you can make a web page, have some of the features of an app, including notifications. And the idea for notifications is we want to be able to have the how are you right now one question form feature, which is, I forget the term for this, but you know, how is this subject feeling at 10 a.m.? How is this subject feeling at 1 p.m. and so on, and have that via a pop-up on the device to have them answer one question in forms. And so that's the way we would achieve that without having to build Android apps and iPhone apps and stuff. Keep it all on the web with notification-based forms on that side of things. And of course, what do you want to see? You know, your researchers and clinicians and people collecting data, how do you think about data and how do you collect data? What do you want added? Or what can you contribute if you're programmers yourselves to add things in? So find out more. We've got docs and advertising and everything. Everything's up on GitHub. I don't have the playground link, but the playground is broken anyways right now, so I have to fix that after this. Thank you very much for your attention.
Wow. You have questions?
Yeah. Yes.
Very nice platforms. Looks like very user friendly. I loved it. The only things that I didn't find in your demo were we could see like the data entry forms, but what about going back and do some researches? Let's say I want to see how many patients I have between 65, 70.
Sure. We're not the primary use case of this, and the thing we're trying to solve right now is collecting and structuring data, right? So we want to have good ways for people to be able to run their instruments, do their forms, and get data structured. There's an export button. You can get a CSV out, right? So you can use R or Python or whatever it is that you care to do, or whatever platform is your preferred method is to then do your own filter on the data that you have access to within the platform. In the future, there is the potential to have query, like the query component within the platform, but that's not our target use case right now because there are other solutions outside the platform that are sufficient.
Okay, so if I understand correctly, you will export all the data?
So that's all that, it's the data that you have access to as your user. So it would be your group's set of data.
So you need to export all the data, and then you need to use filters like in Excel, let's say, and.
Well, a tool that's more suited to managing data like SPSS or R or Python. Excel's not exactly good at that either.
Well, I'm very basic.
Yeah, so
Feel free to Excel for now.
Yeah, so the use case that right now doesn't include a query feature. Because again, we want to capture data first, let me get it. And there's a way to get it out. We're not holding on to it. You can get all your data immediately, right? But there's not really there's no cohort selection.
Because you showed us graphics, and I thought like there was like a way to see reports or.
You can view the summary of any particular instrument. If you click on an instrument in the table, you can see what the summary of the table is.
And so it's only for instruments, or it's in general? Just for the instrument.
I'm not sure what, there's only instruments right now, so that's all there is, that the platform has right now. Yes.
I actually have a question. That's a first. I've seen every movie. Yeah, I deal with every data management tools we have here. So Red Cap, the line survey, all the standard ones. I understand everything's going to be modular on groups. Are they all encapsulated in each other, or else there's going to be communications with each other? Can you promote some data transfer through groups?
We do not have a concept currently of multiple membership of data.
Because like, let's say an example here, we have we have participant data banks, and then those are probably already collected. So we could just promote it, change it to another group, get the information already there, do the setup, skip some steps.
In terms of data insertion, I think if you're asking about that, like you have data somewhere else, you can, the API allows you to just add data in like in a programmatic manner. This would be retrospective in the sense that you get to set the date that the instrument was run if you have historical data. So you can upload data into the platform if you wanted to restructure it using the forms.
Because there's multiple programs, it's encapsulations of every group can be managed by one person, the data manager.
Yes. So the data manager is the one with ultimate power within a group.
Okay. So I can I'm speaking because I'm probably managing it, so anything happens here. Create subgroups, and those can be managed by the.
So that would be at the administrator level for that. Yeah. So the administrator, of course, always has the ultimate power to do that. You can directly modify the database if you want. Like we don't have features for that, but you can. It's a MongoDB, so there's a way to connect and use to directly operate on the Mongo database if you need to. It's like modify things or fix things at that level, or do like group management. So like the admin features are very minimal right now in terms of like it's basic user creation and things. We need to add more API endpoints for those.
Okay, perfect. Because, last little question: Is there any backup tools right now? Anything like that? Because right now Red Cap, you can just take it to a copy completely.
So the concept we have here is that we're providing you a tool to run on your computers, and you are a professional who knows how to back up your stuff.
Okay. It's tools integrated in.
Yeah, there's nothing integrated in the platform.
Red Cap right now, we can just do like, oh, I want the backup of this. I just created them.
Yeah. So our concept here is that you have somebody reasonable Linux sysadmin level. And so, there are tools to connect to a MongoDB and dump it. Perfect. And in terms of the way the platform works, everything is in DB. So you have your environment config file, which sets the very, very basics of the platform. And then everything else is in the DB, including the instruments. So the instruments, if you have versioned updates for the instruments and so on, all that gets logged inside the DB. And so you can dump it out and you can reinstantiate the system again by recreating the database segment so that that manages so we're hoping that the schema, the software updates don't affect the schema of the DB, the way we designed it together. Okay.
I think there's some online question.
Yeah, the question.
And is it
I'm gonna have a hand up.
There's a hand up.
That is online, yeah. So I think there's some of the M&I people here, Patrick.
you can unmute, we can hear you if you want to speak.
Okay, thank you. Thank you for the presentation, Gabriel. I'm really excited about this. Quick question about using it for research. I've had experience before with forms that you can put a consent form at the beginning of the form. You click I agree, and then the questionnaire pops up. Is there going to be some sort of feature like that? How do you see this being incorporated in that aspect, that flow of research?
So there can be instruments that are group specific. So the way that we would conceive of this is that a group, when I say a group could be a research project, a group could be a clinic, a group could be lots of things. And so in that case, what it would be is a consent form would be a form. And so
okay.
It would just be a form that would be completed like any of the others. And it's then the researcher's responsibility to manage their data properly in terms of subjects that have completed consent and subjects that have not completed consent, if you're running in like a hybrid clinical research setting, for example.
Okay. So we could essentially, it would be putting the link on the form. It's like the consent form, or
So our concept of consent form would be, it's an instrument called a consent form.
okay. Oh, I understand. Oh, okay. Okay, great. Thank you.
Is it possible to link a second instrument based on the outcome of
based on the outcome? No, we're something that is definitely demanded by the researchers and is not quite complete, but was being worked on was a series instruments. So the idea being of, well, you have your standard like first visit study series instrument, where the first thing that happens is the consent form, and then it's another instrument and another instrument and another instrument. So we have that concept to be able to present them, but they don't have a conditional layer in between them. They're all the only conditional components are within a single form.
Thank you.
Well,
there was another question.
there was some text.
I think we're just comments. That's it.
I think
So he was talking about if one has access to the PID hashes, they can still check if a PID they know is part of the data set.
Sure, of course, that's the standard kind of rainbow
Right.
tables thing.
So he said,
The solution, so first of all, you make it expensive. You use, you SHA 512 instead of SHA 256. The second thing is you put a salt in the
that's what next team you mentioned.
you put a salt in the system configuration. So you don't store the salt in the database, you store the salt in the config for the environment when you launch the platform. However, if somebody's getting a copy of your database, you're having a very bad day, right? So that's just in terms of the way the security things are going here. Getting a copy of the database to be able to just run everything across is bad news on that.
So, I mean, just like a quick follow-up, because I'm not sure that everybody here has background. So currently is where research work in our center is that you typically have a sort of correspondence with relaying of participants and a unique study ID. It's supposed to actually be physical in a special locker where only a few people have the key. In practice, I'm not sure how strictly that will be followed, but that's how it's supposed to go. And one of the big downside of doing that way is that in practice, that's not what people do. So you may end up, very, very bad security actually happening in life. The other thing is that that's supposed to be destroyed after a while. So if you have longitudinal data being collected at centers, there's no way to know how many times a given individual, came to participate to a study in our place, which is a huge missed opportunity if you want to kind of pull data, right? So with that, you can regenerate. Research teams generate their keys independently. They don't know that the person already come, but they generate it with the same standard procedures. So they end up with the actual same ID.
Yes.
Which means that you can track them people longitudinally, possibly for decades.
So that's the idea, because like at the Douglas, we have 10 clinics.
What's that?
More 10, 15 clinics in the Douglas that you could have an individual attend many different ones. They don't talk to each other in most cases, right? But if they all are using the same data backend, there is potential, subject to REB, ethics, all of the complications of how you actually achieve it, but at least having the data be connectable in the future in a way that is actually usable, because of course the data in many cases is in the EHR system somewhere, but you have the challenge of the data team in the hospital not having the same data wrangling background that we may have in our teams. And in addition, it's usually just free form. And so like parsing out measures about a subject across 15 different clinics is pretty much impossible, right? Whereas if you structure the data ahead of time in a platform like this, then you have the potential to then put it together later.
So our use case here wouldn't necessarily be with the clinical advantage,
Sure.
although this may help. But just like we are planning to pull data across research groups here, it seems like kind of a no-brainer. Let's say if the alternative was a spreadsheet hosted on, let's say, Microsoft products on the cloud, like this is hands down more secure. It's not even actually really efficient.
So the something to, in terms of spreadsheets, since you mentioned spreadsheets, I think an important thing to highlight here is that the instruments that you define, they have two components when you go to build the instrument in the instrument builder. One piece of the instrument design is the UI components of like how, if it's a numeric, is it going to be a field you type in, or is it going to be a slider, or is it going to be a ordered enumerate where you have like a Likert scale or so on. But then the other piece of that is actually there's the validation schema for the data. So that is what is allowed to actually go into the database in terms of data entry. So obviously the form and the schema are built right next to each other. And so it's very easy to make sure that that data is collected properly. But the other part of that is if you do the API upload, that validator is also applied against that, and it won't insert bad data from that perspective, which means that you're never polluting the backend database in terms of having accidentally misentered numbers or so on. Unfortunately, on Excel, you can write validation schemes in Excel, but how many people are in that where you have to? Like this is enforced in kind of the build. And so the idea is that you're not going to run into these cases where you miskey data in quite the same way. If you miskey, it's going to be data that is actually still valid, at least, whatever that means. But it can't be something that's completely broken in terms of the schema, because we know what the schema is all the way down, which allows us to create the visualizations and so on, because we know the data is numeric, for example. Has to be.
The unique edge in months as opposed to edge in years. When you deal with young babies, you may end up with this type of mix-up.
So I haven't thought about that, but the way we've been thinking about age stuff in general is to store date instead, rather than because depending on when you download your data, if you're downloading the cohort representation of your data, there are different ages at different points in when you do the collection. So not having to repeat your demographic measurement at different times to have the age means that you would rather like render an effective age.
I know if there's one last question because I'm conscious of time.
Okay, sorry about that.
No, that's good. We have 3 minutes.
Very quickly, sometimes when we do some tests, we record that for several reasons, like offline, quality checker, or we really need for a graphical production, we need the paper. So with this platform, can we add some audio file or a paper?
Yeah, so as I said, like in the future features, the next thing that people are into and we're interested in or asking about is how to store binary data. So that could be a scan, that could be a recording. So there's somebody at the Douglas who's interested in generating a speech bank for psychiatric disease. And that means having audio recordings. So there's the generic concept of storing binary data on the back end is like, I have done an instrument, it is called an audio recording, here's a file you will store for me. That's the bare minimum feature set, where you can download it again, or you can upload it and store it safely. That's the minimum feature set. Beyond that, then it's, if you then cast that into, okay, it's binary data of a specific type, which has metadata associated with it. I can read it or process it or give a preview of it or something like that. That's an extension on that we're thinking about how we would achieve. One of the design goals is to have a modular processing feature, which is separate from the existing software components, where when new data comes in, it might have software run against it. So in the case of the recording would be something like doing spectral analysis and giving the spectral analysis breakdown, or doing transcription of it, and then storing the transcription in the database. But that is like, we have to think very carefully about the interfaces that will handle and how it will handle it, so that we can have generic processing features that are implemented on that side to consume data and then to feed data back in, or consume data and do a prediction, update a dashboard, any of those sides of things. But that, like, the API has to be really, really carefully designed there. And so we're going to take our time thinking that.
Thank you.
Okay, the last question.
The real one.
Just that also connect biosamples
Our current users are collecting biosamples. We're not talking about biosamples at all, right? As you came in a little bit late. I think by very beginning, my concept of data is things that I can quantify and measure. So if you want to say the assay result of a biosample, I can store that. Yeah. It's an instrument, right? That's all just an instrument that's a form, and you can fill it in. But like, I'm not conceiving of tracking biosamples as like where it is in the fridge or anything like that. But you want to store assay results? Sure, they're just numbers. Yeah, as long as I can, it's quantifiable in some way, I can store it, like you'll form and store it.
You can have just a form with the ID of the biosample associated with the participant.
Yeah, you can absolutely do those kinds of things. Yeah, for tracking. Like, it's not intended as an inventory tracker, but you could build it for those kind of pieces if you want.
Amazing. Thanks again for coming. Incredible.
Thank you.
Yeah.